Hey, hi, good morning, guys. Good morning, good afternoon, good evening. Okay, I hope all of you are very safe and healthy. Okay, so I am back again, and today in this video, we are going to do one very interesting practical demonstration. Okay, that is, let me share my screen. Okay, so yeah, so this is the agenda of the video today. We are going to develop a complete REST API in .NET Core, C#, we will write the API. Okay, and we are going to consume these two services, AWS Lambda. Okay, AWS Lambda, as we know that AWS Lambda is a complete serverless offering from AWS. Okay, and to know more about the AWS Lambda, okay, I have a separate playlist of AWS Lambda, wherein I have explained the AWS Lambda in very detailed manner. Okay, it has a complete series of 10 different videos, more than 10 videos. So you can study about the AWS Lambda with that playlist itself. I'll share the playlist link in the videos description of the video. Okay. So we will leverage AWS Lambda to develop the API. Okay. And as the backend database, we are going to use PostgresSQL. Okay. So PostgresSQL is another open source database engine, database service. Okay. And with AWS, we can provision the Postgres database in two ways. Okay. The first one is we can do the standard provisioning. Standard provisioning means we can set up the complete database server, wherein we will get the database server access also with that setup. Okay, and we can customize the infrastructure, okay, of the database server that we will get, and we can ourselves administrate and manage the server database server itself. Okay, that is one. That is the standard installation of PostgreSQL with AWS infrastructure. Second one is another AWS database service, that is AWS Aurora database service. Okay, AWS Aurora database engine that provides us the feature to create the PostgreSQL database or the MySQL database. Okay, in serverless manner, wherein AWS doesn't provide us the access to the underlying infrastructure. Instead, from the AWS console itself, we can manage the database. Okay, and it is completely serverless. Okay, so there's two different flavor of PostgreSQL installations there in the AWS console. Okay, so for this demonstration, we are going to use PostgreSQL. We will create the PostgreSQL database, okay, in AWS console with AWS Aurora engine. Okay, that is again the serverless offering from AWS, and there is a lot of benefit with going serverless in terms of the cost effective, and also even there's some standard features that comes with all other AWS services that we will discuss in coming slides. Okay, so yes, yeah, one more thing, that this complete demonstration I am going to cover in two parts. Okay, in the first part we will understand about the PostgreSQL creation of the PostgreSQL database on AWS console with AWS Aurora engine. Okay, that will be one, and we will also understand the features of AWS Aurora database engine. Okay, and then we will jump onto the AWS console, and I will demonstrate you how to create a PostgreSQL, how to set up PostgreSQL database instance with AWS Aurora in serverless manner. Okay, that will be the part one, and in part two we will jump into the Visual Studio, and we will develop the REST API with AWS Lambda, and that API is going to connect with PostgreSQL database that we will create in part one in order to communicate it, and we'll see the get and post method with the underlying table itself. Okay, that will be the second part. Okay, so I would request that please continue to the till end of the video in order to understand the entire demonstration. Okay, and to get you well get the well understanding of this entire API development itself. Okay, so let us understand some important feature of Amazon Aurora database itself. Okay, So Amazon Aurora is a fully managed relational database service offered by AWS that combines the performance and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. Some key features of AWS Aurora are. So what we are used to do normally, like if we have to set up a database, okay, we get a server, we get a EC2 instance, or we get a virtual machine, okay, and there we install the database server itself, whether we are going with Microsoft SQL or MSS, MySQL or the PostgresSQL. We will download the installer. Okay, so MySQL and PostgresSQL is open source, but MS SQL is not the open source. It is we read the license from Microsoft. So we will install the server, complete server. We will install within the EC2 machine. Okay, and then after we can deploy the application that will be connecting that database, and the application will keep on running itself. Okay, but the constraint here is we need to keep the server keep active and running entire 365 days. Okay, and the additional the charges will occur on us even the application is working, or even our application is running or not. Okay, we have to pay the charges for the entire server. Okay, that is the constraint of the traditional way of installing the database server on EC2 machine or the virtual machine. But with Amazon Aurora, that is not the case. Okay, so it is completely serverless and it is fully managed by AWS itself. Okay, as we do, we can create two type of database: PostgreSQL database and the MySQL database with Amazon Aurora in database engine. Okay, and it is completely serverless in manner. Serverless means it creates it configures and provisions the underlying infrastructure, like the whatever resources, memory, storage, and CPU it will require. It will configure in the background, but we don't have to be concerned about that because it's all on AWS. We will only get the console access on the AWS console. We will get the access wherein we can access our database, we can query our database, and we can do all the configuration of the database itself. All the configuration and properties we can define on that itself, on the console itself. Okay, and serverless in the term, like it is already cost altogether cost effective also, because AWS it is pay per use model. The charges are pay per use. Okay, AWS charges us only for the time the database is active and running. Okay, and accessible from the connected applications itself. Okay, and there are more other features, like it is a high performance. Aurora is designed for high throughput and low latency performance. It can deliver up to 5 times the performance of standard MySQL and 3 times that of standard Postgres database itself. So comparing to the traditional installation of MySQL or the PostgresSQL into the EC2 machine or the virtual machine, okay, Aurora, if we are going with the Aurora version of these databases, MySQL or the Postgres, okay, it can give you the 5x faster performance with MySQL and 3x faster performance PostgreSQL itself, comparing to the traditional installation of these databases, okay, without Aurora engine. So that is the first. It is a scalable also. Aurora can automatically scale storage from 10 GB to 128 GB, okay, as needed with no downtime. It supports up to 15 read replicas to handle read-heavy workloads, high availability and durability. Okay, let us understand these terms. In case of the standard installation, like we have installed the database in EC2 machine or the virtual machine, and in the situation where the size of the data getting bigger and it is growing day by day. Okay, and after that we will start getting the performance bottleneck, and in that case we will need to increase that storage. Okay, in order to increase the storage, we need to shut down the machine. Okay, we will get that we'll have to plan the downtime, and we will need to increase the volume, and then we can restart the database again. Okay, so that is the case with traditional installation. But With Aurora, because it is serverless, okay, so it can even in case of the data size or the volume increases, requirement increases, okay, Aurora can automatically scale the database from 10 GB to 128 terabytes, okay, as and when required, okay. It scales itself, or it can scale. It can also scale down itself, okay, without downtime. We don't need any downtime. Application is keep on running, okay, and it can handle the heavy workload because it is also it supports 15 read replica, okay. So with Aurora itself, it creates a database cluster, okay, and there is one primary instance of the database will be created that is having the read write facility itself, wherein we can read and write, we can do both the activities. But apart from that, AWS Aurora can create the 15 read replica, okay, the replica of the same server, where in read actions can happen on those replica instances itself, okay. So let's say you have hosted an application, okay, and primarily you have created only one instance of the database, and on the same instance you are doing the read write activity both, okay. Later on, when the users increases on the application, okay, and you feel that the application is getting heavy workload, okay, and you started facing the performance issues. In that case, what you can do, you can divide the application, you can route the application. All the read requests you can route to the read replica, and all the write requests will route it to the primary instance only, okay. In that case, application will get the best performance, and these replications happens in the backgrounds asynchronously, okay, and we don't have to worry about that. It's all managed by the AWS itself, okay. So that is the second very important feature, that is the scalability and the read replica, okay. So with the help of read replicas, the applications we host with this database in Aurora engine, it handles a high availability and high durability, okay. Aurora replicates the data across multiple availability zones and continuously backs up your data to Amazon S3, okay. It all manages in the background, okay. As we discussed, like replications happen, like you have created a database in one zone, okay, and you can configure the replication in different zone itself, okay, in order to avoid the data loss itself. And AWS automatically backs the database in the background itself to Amazon S3, okay. So or also, if the primary instance of the database that you have created, if that gets failed for any reason, okay, the application can the subsequent read replica instance that we have created, that will become the primary, okay, and then you can configure the another read replica to be created for the replication purpose, okay. So that is the failover feature of Aurora engine, okay. So all these the standard features of AWS that comes with all the services, okay. Serverless option, as we discussed earlier, like AWS Aurora provides a serverless feature of database configuration, okay. It's automatically adjusts the capacity of the application as per the need basis, like when the traffic or the users grows on your application, okay, and if there is a need to increase the volume or the capacity of the database server, it will automatically scale up, okay, and when the load comes down and the traffic goes down, in that case it can scale down itself. So all the resources will be scaled down automatically. So that is the serverless feature of Amazon Aurora database engine. Next one is the global database. Aurora global database allows for low latency global read and enables cross-region disaster recovery. Okay, as we discussed that we can create the read replica, okay, of the database. So read replica can be done, can be configured to be prepared across different zone, okay, availability zone, even different region also, okay, different geographical region you can create the read replica. Like if you have created your primary database instance in Mumbai region, okay, AP South 1, that is called. And if you want to create the and you have the facility to create the read replica in different zones, different geographical zone, okay, in US zone or the different zone itself, you can create the read replica. Okay, so in that case, there is a very low chances of the data loss. Okay, and in case of disaster, like in case of primary zone gets any disaster or any failure, then we can route the traffic, all the traffic of the application uh, to the replica zone itself, where we have configured the read replication instance. Okay, so that is all about the global database. Okay, more other features are like with MySQL and the PostgresSQL database, we may have the multiple extension. Okay, application extensions are there. So Aurora is flexible and very compatible to integrate all those extensions with these databases. Security is that the AWS Aurora is highly secure. It is we can connect with AWS Identity IAM service, or we can configure the Aurora database in a private VPTs in private subnet itself. Okay, and we can set up the database in different network isolation. Okay, because as we know that if we set up a database in a private subnet of the VPC, so it will not be directly accessible throughout the world. Okay, it can be accessed only from the applications that we host in the connected public subnet. Okay, so all those the network isolations can be done with the help of AWS IAM and the VPC configuration itself. Automated backup. Okay, so we can configure the while creating the database on with AWS Aurora, we can configure that what will be the retention period, what will be the backup period. Okay, then after AWS automatically will take care of that. That on scheduled time the backups will be created and will be saved to the S3 itself. Okay, and we can restore the backup at any point of time. Okay, within that retention period. So all those managed features are there with AWS. With AWS Aurora Console, we have the performance insights, the complete console, okay, and the dashboards where we can really see the performance of the database, okay, in terms of CPU performance, memory, all those memory and the uses, okay, all those performance we can observe and the monitor from the monitoring panel, okay, from Aurora Console itself. Next one is cost effectiveness. That is also the primary one. We only pay for the resources we use with a pricing model that includes storage, IO request, and the backup storage, allowing for flexible cost management. Okay, as it scales up, scales down, and provisions the server on the need basis. Okay, it is not going to charge us for the whole 365 days. That is the case with traditional installation where we occupy the complete EC2 machine or the virtual machine. But here, AWS will charge us only for the period, for the time our database is active, okay, and the resources are being used. Okay, in that term, it is completely cost effective. Okay, so all these were the features, the key features of Amazon Aurora database engine. With MySQL, the PostgresSQL, these two databases engine we can create with the help of on the Amazon Aurora platform. Okay, so that was all about the theoretical concept of Amazon Aurora database engine. Let us jump into the practical session, and we'll see how to create and configure a database with AWS Aurora, and we will get the database connection credentials, and we'll try to connect the database from our local machine. Okay, so here I am on my AWS console. So what I'll do, I'll go on RDS, Relational Database Service. Okay. If you are on the dashboard, we can search here with the RDS. Okay. Or on the panel, all the recently visited services will be there. If it is not there, we can search from the search input box, RDS, and click on Relational Database Service. Okay. And scroll down. Yeah, here we'll get the option, the create database. Okay, so RDS is the relational database service from the AWS, and it provides the feature to create the database instance with the following databases. Okay, like MySQL, PostgresSQL, MariaDB, Oracle, Microsoft SQL Server, and IBM DB2. Okay, but all these MySQL, PostgreSQL, MariaDB, Oracle, Microsoft SQL Server, and IBM DB2 are the traditional, the complete server setup with the data for the database server. But these Aurora MySQL compatible and Aurora PostgreSQL compatible. These two are the serverless offering from AWS. Okay, so we can create the database engine with MySQL or the PostgreSQL in serverless manner. Okay, that we discussed in the previous slides itself. Okay, so for this demonstration purpose, we are using PostgreSQL, but you can use the MySQL also, or the API we are going to develop that can connect to any database. Okay, just for the demonstration purpose for this session, I have opted to go for the PostgreSQL compatibility. Okay, so I'll select PostgreSQL, and yeah, here's the option: choose to database creation method, the standard create and easy create. Okay, so there are in the standard create, you will get all the options. Okay, like what will the username, what will the database name, and all different options you will get to select. Okay, but for this demonstration purpose, we will go with the easy create, that will create the database quickly. Okay, and I'll select this option, PostgreSQL Aurora, and I'm selecting this option, dev and test purpose, because we are not creating the database for any development production uses. Okay, it is just for the demonstration. So I'll select this dev and test. Okay, database cluster name. Okay, as we say, the first AWS creates the database cluster. Okay, within the database cluster are primary database instance or the read replica database instance. All those instances will be created. Okay, so what will be the name of the cluster? Database cluster we can specify here. I'll keep this as it is, database 1. Okay, master username will be the Postgres itself. Okay, and for the password, I will select self-managed. Okay, and I will auto-generate the password. Okay, so on click of create database, so it will reveal us the password. We will copy the password from there itself. Okay, and that's it. All the options are optional. Okay, we can issue to machine. Okay, yeah, these are the review one. Like okay, so that's it. Let us create database. Database is being provisioned. By the time we can see here the button view credential details. Okay, let us create on this, and these are the database credentials that we will use to connect to the database. Okay, so let me copy all this. This is the host name. It is the password, and the username is Postgres. It is the default username. Okay, so database cluster is ready, but still database instance is being provisioned as of now. Okay. There is one more feature, like by the time it is being created, okay, we can see there's a query editor. Okay, so query editor is the option wherein it provides the feature to query the database from the console itself. From the AWS console itself, we can query our database tables itself. Okay, so I'll see we will see that those also, like how that is working. But let us first the database instance be get ready for us. So by the time this instance is getting ready, I'll explain you one thing. For the MySQL, in order to connect this database from our local machine, we need a tool that is called pgadmin. Okay, so pgadmin is the tool. Like for connecting Microsoft SQL database, we need the management studio, Microsoft SQL management studio. In the same way, uh, for connecting this PostgresSQL, we have the tool pgadmin. Okay, so with the pgadmin, we can connect this database with using these credentials that we have copied from the AWS console itself. Okay, so and how we can install this pgadmin? So for that purpose, what we can do, we can go on this URL, Windows installer you can find for the PostgreSQL. Download the installer, click on download the installer. Okay, and from this, for the as per the operating system you have, you can download the installer. Okay, and for this purpose, Windows 64 architecture, you can download this installer. This what it, after getting the installer, you can install this on your machine, and this will create the PostgreSQL database server on your local machine, as well as it will install this pgadmin tool also. Okay, with that you can use to connect any PostgreSQL database instance. Okay, so all those setups will be there. I'll post this link also in the description of the video, so you can do get the setup also installed on your local machine. Okay, so that was one thing to explain, and our database instance is still being created. I hope it will still take few more minutes. Let us wait few seconds. Let the instance come online, then we will connect back. I'll pause the video for few seconds. Okay, guys. So this it is still configuration, and okay. So database instance is created, I hope, but yeah, okay, it's available now. Okay, so let us try connecting this database from the management studio. Sorry, pgadmin itself. So on the server node, Okay, we will right click here and we'll click on server. We'll register a server. Okay, demo db Aurora. Okay. In the connection tab, we will specify the host name. Okay, and default port of my PostgresSQL is 5432. Username is this one, username itself. Maintenance DB, let it be default, the Postgres itself. And the password, we have the password. We will put the password here. Okay. Let us save the password and try to connect. Let's see what happens. It is not connecting, unable to connect to the server. Timeout expired. Okay. So why it is happening? I'll show you. Like we have created the database just now, but for the database, what we have to do, this database is created, but it is still not having any public access. Okay, we have not exposed the database to connect from outside world. Okay, so for that, what we have to do, okay, we will select here the database instance. Okay, we'll click on we can create here. We will modify it. Okay, and in the connectivity section, okay, it is IPv4 itself, and yeah. In this additional configuration, you have to enable this option publicly accessible. Okay, because currently it is not accessible publicly, and the default database port is 5432. That is correct, but it is not, the port is not exposed outside world to the outside world. So I'll enable this option publicly accessible, and we'll save this. Okay, let me check it again. I think there is one more option here. Additional configuration publicly available, and okay, continue. Okay, so this, yeah, also this option we need to select to take this change if to be applied immediately. Apply immediately. Okay, and modify DB instance. Is to modify the database instance has failed. Database instance is not available in available state. Okay, why is that? What is happening? Okay, so it is modifying now. Let this modification complete, then we can make this change. There are further more configuration with this database instance, like snapshots that we can use to create the snapshot to take the backup. Okay, exporting, we can get the backup in the Amazon S3 itself. We can configure the automated backup of the database. Okay, what will be the retention period and all those things we can configure. Okay, and all other features are there that we will see in the later videos. Modified successfully. Okay, database is still it is configuring. Yeah, so it's connected now. Okay, so we are able to connect the database. Okay, and this is the default database Postgres. Okay, and there is an another database RDS admin, that is the default one. Okay, so no data. Okay, let us create a database new database here. I'll create one. I'm creating a new database. Okay, sensor data. The name of the database is sensor data. Okay, and let us create this. Owner will be the Postgres. The default username and owner of this database will be the Postgres itself. I'll save this. Our database is created here. Okay, next, the schema, in the public schema, in the table section, we can create the table itself. So let me create a table also. I'm creating a table register data. Okay, owner will be Postgres, schema will be public. In the column section, I'm defining the table columns itself. Okay, so register ID, device ID, and you can specify the type here, like let it integer, integer, device date time stamp without time zone. Okay, yeah, blue, that is numeric. Data quality, that is integer. Okay, so I have created a table structure here. Okay, this table structure basically we configure in with to collect the data from the IoT devices, where each registers sends the data from its device every minute. Okay, and it is having a raw reading as well as the normalized reading based on the formula. Okay, and the data quality, whether the data is good or the bad data or the faulty data. Okay, so with that concept, I am creating a register data table here. Okay, I'll save this. Okay, and let me edit and put some records into the database. Okay, so let me put script. Okay, so register ID 1, device ID 1, device DTM, I'll put 5. Raw value 45 point, this normalized value, let's say 45.7, it will be rounded up. Okay, and data quality 1. Insert one more record. Sorry. So register ID will be 1 itself, device ID 2, second device. Okay, and date time, let's say 50, 33, 34. Data quality will be bad. Okay, one more record. Register ID 1, device ID 3. Time will be 5, 22, 23. Okay. So I have inserted 3 records in this table. and we can verify. Let's start. Register data. Okay. Only two records, 1 and 3. 2 is not inserted. Okay, it's 3 records now. Two records are for the bad quality, 1 record is the good quality. Okay. Coming back to the console itself, we can go into the database. Okay, we can go into the query editor. See, this query editor, no database that supports query editor. Okay, so currently query editor only supports Aurora serverless database. Only Aurora serverless database that you have access to will be displayed. To use the query editor for database must be have the data API enabled. So in order to use this query editor to connect our database and to query our tables, okay, what we have to do, we have to enable this data API. Okay, that is the feature of Aurora database that we need to enable. After that, we can query the database from this query editor also. Okay, so let me check this whether we have the option to enable that. Okay, so I think we have opted for this one, the easy create of the database while creating the database. Okay, so in order to get this data API features available, we need to go for the standard process. Okay, like when you are creating the process database, let us I'll show you from the standard create. Okay, and if while selecting this Postgres one, we will get the option here. Yeah, so this option, RDS data API, enable this RDS data API. Once you will opt this option, okay, then we can connect the database from this DB instance, from this query data itself. Okay, so it is simple. Like the query data, we can specify the connection credential, and it will be connected. And from this, the query data you are seeing in the background, you can put your query, the same query what we are querying here. Okay, and all those query will be executed on this console itself, and you can verify the database, the data tables itself. Okay. So that thing you can try at yourself. Okay, that for your experience, you can try all this activity on your free tier AWS console. You can create and you can try all this activities itself. Okay, so that was all about creating the Postgres database with Amazon Aurora database engine on AWS console, and we understood about the what is PostgresSQL database and how we can create the PostgresSQL database instance with Amazon Aurora on AWS console, and how we can connect the database. We have connected the database from the PG admin, the connecting tool. Okay, we have created a sample table. We have inserted some sample records. Okay, and we have verified that. Okay, so that was the part one of this video series. In the second part of this video series that I will be publishing very shortly. So in that we will develop this complete REST API with this in C# .NET Core that will be connecting this database that we have created in order to push the records from the API and to read the records from there itself. Okay, so let's wait for the next video session. By the time, thank you very much, guys, for joining the session. Okay, stay healthy, stay happy, stay connected, and if you find my video informative, I would request that to please like the video and subscribe to my channel, so that you will get the automatic notification for all the upcoming videos from my channel itself. And it is really it really motivates us to create more such interesting videos for the community. Okay, thank you very much. Thank you very much for now.